In section 4.3, we're going to look at a certain type of probability, and it's called the addition rule. And so in these situations, we're going to see compound events. So we're looking at what is the probability that this event or this event could occur. And so a big thing to remember that will make this a lot easier is that every time we see the word or, that always means to add the two separate probabilities together. So or means add. Now let's look at some definitions. The addition rule is applied when finding probabilities that can be expressed as P of A or B. To find the probability of an event A occurring or an event B occurring, we begin by finding the total number of ways that A can occur and the total number of ways that B could occur. But we find that total without counting any outcomes more than once. So sometimes we deal with situations where the probabilities overlap each other. So in events when A and B can occur at the same time, then the probability of A or B is equal to the probability of A plus the probability of B minus the overlap, or we subtract the probability of A and B happening at the same time. Now, a probability situation that I can think of that applies here would be maybe dealing with a deck of cards, and we're saying what is the probability of selecting a red card or a king. And so it can occur at the same time that you get a red card that is a king, and so in that situation we would have to use this type of a formula where we add the two separate probabilities but then subtract the overlap. In events when A and B cannot occur at the same time, or we call those events disjoint or mutually exclusive events, then the probability of A or B is simply the probability of A plus the probability of B. So one thing that keeps repeating here is that or always means to add. Then we have some complementary rules dealing with probabilities. When we add the probability of A with its complement, we get 1. The probability of A occurring is 1 minus the complement. And the probability of the complement is 1 minus the probability of A. We're going to practice understanding if two events can occur at the same time or not. So we're going to determine whether the two events given are disjoint. Disjoint means separate or not overlapping. So could this occur at the same time or not? Randomly selecting a fruit fly with red eyes and randomly selecting a fruit fly with sepia or dark brown eyes. Since we can't select a fruit fly that has red eyes and sepia eyes at the same time, this would be a disjoint event. Now let's look at another example. Can this occur at the same time? Receiving a phone call from a volunteer survey subject who opposes all And let's look at one more example. Can this happen at the same time? Then we also need to understand how to find the complement of an event if we're told what the probability of that event occurring is. So what we do is we just subtract the given probability from 1. So if we're told that the probability that A occurs is 0.01, then to find the opposite of that event, or the complement, we just subtract the number from 1 to get 0.99. Here's another example. A poll showed that 61% of Americans say they believe that life exists elsewhere in the galaxy. So what is the probability of randomly selecting someone not having that belief? And this is something that you could see on a test, and people tend to miss it because they make it harder than it is. So if 61% say that they do believe life exists elsewhere, then the opposite would be subtracting that from 1, or 100%. And so the opposite would be 0.39, which corresponds to 39%. Now here's an example where we have a chart given to us, and so let's look at how to read this correctly. We have a table showing pedestrian deaths in car accidents, and so in this table we're looking at, was the driver intoxicated, yes or no? And then up above we have, was the pedestrian intoxicated, yes or no? And so when we read across, the number 59 in that box corresponds to a yes and a yes, meaning that 59 deaths occurred when the driver was intoxicated and the pedestrian was intoxicated. And then the biggest number that I see, 581, represents the number of deaths that occurred, and that's no, no, meaning no, the driver was not intoxicated, and no, the pedestrian was not. If one of the pedestrian deaths is randomly selected, find the probability that the pedestrian was not intoxicated or the driver was not intoxicated. So in this probability question, we actually have two different events, and it's linked by the word or. So remember that whenever we see that, or means to add the two separate events. So the probability that the pedestrian was not intoxicated or the driver was not intoxicated, well, what I need to do is add first that first fraction you see as I'm solving for the number of pedestrians total that are not intoxicated. So the number of pedestrians that are not intoxicated, you're looking at that vertical no column that I circled, and that's 79 and 581. And that's divided by 985, because 985 is all the numbers added up, 59, 79, 266, and 581. The second fraction represents the probability that the driver is not intoxicated, so the numbers that I'm adding on top are the numbers that correspond to where the driver was not intoxicated. So that's that bottom row that I circled, the numbers 266 plus 581. That's also out of 985 total. Then I subtract the overlap. Could this happen at the same time? So you can see that when I circled the corresponding row and the corresponding column, they both overlapped at the number 581, meaning I used that number twice. So I need to subtract the overlap. So I subtract 581 out of 985. So let's move on. Here's the next step. This now gives me 660 out of 985 plus 847 out of 985 minus 581 out of 985. And so what I did is I just went across the top and I did 660 plus 847 minus 581, and that gives me 926, and I just kept the common denominator 985. Your final step is to divide that fraction. 926 divided by 985 equals 0.940. So you have about a 94% chance when you randomly select one person that in that situation the pedestrian was not intoxicated or the driver was not intoxicated. Here's another example that corresponds to a table where we have different blood types, and then we have the groups listed as well. So we have Rh positive and Rh negative, and then we have group O, A, B, and AB blood types. And so in this problem, if one person is randomly selected, let's find the probability that the individual is group B or type Rh positive. So I've highlighted the word or in red because or means to add, and then the probability on the left is the number of people that are group B out of the total people in the chart. And then the fraction that would be on the right is the number of people total that are Rh positive out of the total people in the chart. So let's look at how we set this up. The probability of group B or type Rh positive. Well, the first fraction is 10 out of 100 because there's 10 people that are group B. Now, how did I get 10? Well, if you look in the table, group B is the vertical column, and I added 8 and 2. I add that because it's OR, and my second fraction corresponds to the total number of people that are type Rh positive. That's 86, and I got 86 from looking at the Rh positive top row, and I added all of those numbers in that row together, 39, 35, 8, and 4, and I got 86. The denominator 100 is the total people in the table. Now, can this happen at the same time? Well, yes, when I circled the row and the column, I overlapped at the number 8. So I have to subtract the overlap, 8 out of 100. And so when you add 10 and 86 and subtract 8, you get 88 out of 100, which equals 0.88.